All right, this lesson we are talking about solving systems of equations again. We're still back on that, but hopefully you noticed that there's a need to do this in a more efficient way than graphing. Graphing is good because it's visual and you can actually physically see what's happening, but the reality of it is if you're going to do this and you're going to do it with any kind of speed and accuracy, you have to do it algebraically. It's really the only way to do it. And all that means is we're going to solve these equations using algebra. So I'm going to show you a couple different situations. We're going to use the same method throughout. We're going to use this method called substitution. You guys know what substitution is. Substitution is basically the same kind of thing that if I say, hey, I have the equation, or I have the expression x plus 4 and x equals 2, evaluate that. And then you would just put 2 in for x and go 2 plus 4, and then you'd get 6, right? And that's a very simplified but very basic and accurate depiction of substitution. So what we want to do is use substitution with equations, and I'll show you how to do that. So let's take a look at this first problem here. It says solve the system of equations algebraically. So what you got to recognize when you're doing something like this is we need to have something equal to a variable. We need to have like a variable by itself with a coefficient of 1 and then everything else on the other side. So if you look at these two equations, I've got one equation that says, well, the variable y is equal to x plus 4. So great, we got one of those, right? And then the next equation says the variable y equals 2. Well, here's the thing. Both equations, we want to find out the case when both of those are true. So what I should realize is that the same y that tells me that y is equal to 2 will be the y that tells me that y is equal to x plus 4. So what's great about that then is you can use that and you take one of the equations, y equals x plus 4, and then instead of writing y down, we're going to take what y is here and we're going to substitute it in there. So we're going to take out this y and we'll put in, let's do pink. All right, we'll put in 2. And that is my substitution that I've done. I decided to take y equals 2, and I'm putting that right here on this side, and I'm substituting it right here for that y. And then you write down the rest of the equation, and then at this point it's just solving a multi-step equation. In this case it's a one-step equation. All right, so we've got x plus 4 on this side and we've got 2 over here, so let's subtract 4 from both sides. We do that and we get x, and then 2 minus, sorry, that's supposed to be a subtracting 4, I think, because I have that arrow there. 2 minus 4 equals negative 2 is what my x coordinate is. And then all you got to do is, if it doesn't tell you what y is in the equation, you're going to have to put your x into one of those to figure out what it is. But this one does. All right, it gives us the point negative 2, and then we use this y equals 2. So that's saying this point right here is the point where these two lines cross. And if you think about a graphic representation of this, y equals 2 is a line that looks kind of like that, right? Where this would be that, and then we've got, and then y equals x plus 4 is a point that would cross right here, and then a slope of 1, so it's going to be about right there, which is, yeah, that looks right. Negative 2, 2. Okay, so let's try another one. Y equals x minus 9 and y equals negative 4x. So again, we have a situation where we're saying, well, y equals this, but it also equals this. So all we got to do is just set those two things equal to each other, and then once we do that, solve for x. So we'll take x minus 9, and we'll set that equal to negative 4x. So the negative 4x went over on this side, This x minus 9 went over there, and then you just set up a usual, your usual problem solving framework that we use. All right, so we've got x over here, a negative 9 over here, and then we've got x's over here. So let's move this negative x over to the other side. All right, and so you've got negative x, taking x away, you got negative 9 right here, and then negative 4x and negative x gives me negative 5x. And then if I divide both sides by negative 5, because you got to do one thing to one side, you got to do it to the other, and that gives me 9/5. All right, and then the last thing I have to do is I've got to take this x value and I got to put it in one of those equations to figure out what the y value is. So I'll put it in this bottom equation because I think that'll be a little easier. So we have y is equal to negative 4 times 9/5, and then negative 4 times 9 is negative 36/5, and then your solution would be the point 9/5, negative 36/5. And if you put 9/5 in this equation right here, right, that would be a good way for us to test this and see if we're right. Well, 9 is negative 45/5, right? So this would be 9/5 minus 45/5. Well, 9 minus 45 is negative 36 over 5. So it looks like this works. And a lot of people might think, oh, this is no way this could be correct because you get such ugly numbers, but it's correct. All right, so in the next video, we'll look at how do we do this when we don't have problems in slope-intercept form all the time.